Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 48 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we are using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is how to control a DC motor using the Arduino and to control both its direction and its speed. Okay, now this is actually a homework assignment that I gave you last week, and today I'll show you my solution to the homework assignment. But since it was a homework assignment, I should stop and ask how many of you were successful. If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, guys, hopefully you were able to do it, because really last week I talked a lot about controlling that motor, controlling that little motor in the kit using the TA6586 DC motor controller also in the kit. And then what the assignment was to go in and kind of add the direction control and the speed control. All right, now let's come over here. Let me jump on over here and let's look at my circuit for this, and then we'll talk a little bit more about the homework. Let me see. I think this would probably be a pretty suitable view if I got out of your way. And so what you can see here on our circuit, we have a potentiometer, and we're going to use this potentiometer to control the speed. We have a button, and we're going to use this button to control the direction. And then we have the motor controller over here. All right. Now, how do we have this thing hooked up? Let me just talk a little bit about hooking this thing up, and then we'll jump in and we will start talking about sort of the strategy for the code. So we'll kind of map out a strategy before we jump over and start coding. But before we can do any of that, we have to get this thing hooked up. Okay, so let's start with the motor. And if we look here at the motor, you can see, well, I guess I should talk about the motor controller first. This, as I said, is the TA6586 motor controller. And a lot of the motor controllers are very simple, behave very similarly. So even if you don't have this one, probably the one you will have will operate a lot like this one. But this one, we've got to get it hooked up, so we've got to understand its pin out. And what we learned last week is all of these integrated circuits have a little code that shows you which pin is which, and it is indeed this little notch. Okay, this little notch tells you how the pins are numbered, and this one has 8 pins. But you go to the left of the notch, and that is pin 1, 2, 3, 4, around the horn and back up, 5, 6, 7, 8. And I put like one too many pins on there, it looks like. So just ignore that one little pin up at the top. But you find the notch, you put the notch up, and then the pin to the left of that is 1. Then they're numbered sequentially coming down, and then however many pins you have, you go across, and then they start numbering back up. So you sort of go down around the horn and back up. Okay, so for this particular TA6586, I have the notch here. The notch is to the left like that. So just make sure that you plug it in like that. Then you are going to know, if you do that, that this is going to be pin 1. And we can see that we have pin 1 on the IC connected to pin 10 on the Arduino. Then we have pin 2 on the IC connected to pin 9 on the Arduino. Okay, and so those are the two control lines that control the forward or the reverse direction. Okay, those control the forward or the reverse direction. So pin 1 on the IC, pin 10 on the Arduino, pin 2 on the IC is pin 9 on the Arduino. Then the next, which is pin 3, we have that connected to the ground rail. We have that connected to the ground rail. And then we have on the IC pin 4 connected to the power rail. Okay, so we have all of that. We have the power, the ground, and the control signals all hooked up on the top. And then you just plug the motor into the IC pin 6. That's not the IC pin 6. That is the IC pin 5. So 1, 2, 3, 4 around the horn. This is 5. And then you plug the other lead into pin 6. So the motor is going to pin 5 and the motor is going to pin 6. Now, it doesn't matter what direction you plug the motor into, which wire goes to 5 and which wire. Did I say 6? That's 8. Oh my goodness, I am misspeaking. Okay, so we have one wire going to pin 5 and we have the other wire going to pin 8. So 5 and 8, like that. Very good. I think we are all straight now. It doesn't matter which wire goes to 5 and which wire goes to 8. That will just control what the forward direction is. So if I put it in this way, it's going to run one direction. If I put it in this way, it's going to run the other direction. And then from the control chip, we're going to have a forward direction and a negative direction. And so there's no real standard for what is forward and what is backwards. It's just forward and backwards will be opposite of each other. Then also just a kind of a reminder of how this thing works in the circuit, that we have that BI, we have the BI pin, and it is connected to pin 1, and we have the FI, the forward input. So this is backwards input, forward input. The backwards input is pin 1, and then the forward input is pin 2. That is connected to pin 10 on the Arduino and pin 9 on the Arduino. So this is the chip. This is the Arduino. And if we have both of these set low, we will be off. Okay, if we have low for the backwards and high for the forward, we will go forward. And if we have high on the backward input and low on the forward input, it will go backwards. Okay, so that's a little truth table of how that thing works. And then also what we saw is on those pins 9 and 10, if we don't just put a high, if we put a PWM signal, an analog out, a signal between 0 and 255, it will actually control the speed. If we apply a 0, it'll be off. If we apply a 255, it'll be full speed. And it will sort of linearly go between those two values. But we saw that the lowest applied value that will actually reliably make the motor spin is about 50, and the maximum is 255. So instead of going from 0 to 255, we want 50 to be our lowest speed and 255 to be our highest speed. And so because of that, last week we came up with a little equation, and what that little equation said was that we could get the motor speed, that right value, and that would be equal to 205 divided by 1023 times the potentiometer value, the value that we're reading off of the potentiometer, and then plus 50. And that way, what will happen is when the potentiometer is all the way to the left and reading 0, we will apply a 50 to the motor controller, which will be its lowest speed. Then when we spin all the way to the right and we're reading 1023 off the potentiometer, then we will be applying 255 to the motor, and that'll be full speed. If that does not make perfect sense, go back and watch last week's lesson. Okay, so we talked about the motor, we talked about the motor controller. Now let's talk about the potentiometer. The potentiometer, we're going to read between 0 and 1023, and then we'll map that onto 50 to 255 through the equation that I just gave you. But the right leg of the potentiometer I have connected to the ground rail of the power board, okay, of the breadboard. And then the middle pin of the GPIO, the middle pin of the potentiometer comes up to pin A5 up here. Let me make sure. No, it's A0. I'm sorry. I can't read that small writing there. So it's going to come up to A0. All right. Now, what you might be tempted is you might be tempted to come over here, and the left leg, which is the power leg, you might be tempted to come up and connect to the power rail here, the 5-volt power rail, but you cannot do that. And I will show you why you can't do that after we start working with this. So what I will just tell you for now, and you'll take my word, that left leg comes up to the 5-volt pin on the Arduino. Okay, so we have that all hooked up. We have that all hooked up. That's very good. Now we have done the motor, we've done the motor controller, and we've done the potentiometer. Now we're going to come in and we're going to do the button. The right pin of the button goes up to pin 7 on the Arduino, digital pin 7, and the left leg of the button goes up to the ground rail on the Arduino. Now, what I want you to see is we have the whole thing powered with this board volt. Is this called? Yeah, I think it's called the board volt, little board from the Arduino kit. And what this does is this creates, when we plug this in, this creates a ground rail here and a ground rail here, and then it creates a power rail here and a power rail here. If we come over and look at the actual circuit, you can see this here. And what I should show you is, that these jumpers, when you're oriented like these yellow jumpers should be at the top and connect the 2 pins that say 5 volts. These need to be at the top and connect the 2 pins that have 5 volts. And so that will set your outputs to 5 volts. And then this is plugged into the breadboard. But make sure you plug it into the breadboard in a manner, okay, got that a little too close, okay, in a manner where the pins labeled plus are going to the red line and the pins labeled minus are going to the blue line. So positive is red, negative is blue, and so that's kind of the convention. Over here, you see we've got this set at 5 volts. The plus goes to the red and the minus goes to the blue. Now, if you took this and you turned it around and plugged it on the other side of the board, everything's going to be backwards. So just make sure that you have this set up so that the red line will be the power rail and the blue line will be the ground rail. All right. Always when we're using this particular one has a battery on it. So we want to make sure that we do not short this thing out. So when you put this back in your kit, make sure that you have it turned off. Make sure this jumper is at the center center position labeled 0 volts. This one's in the center position labeled 0 volts. Put your output pins back in the foam, put it back in the little Mylar bag, because you don't want to just carelessly throw this thing in your kit and maybe end up somehow shorting this thing out. So when you put this thing back in the kit, make sure that you deactivate it by putting the yellow jumpers back to the center position. So we always want to be careful anytime we're dealing with these little LiPo batteries, because they can get overheated. There can be all types of problems if you short them out. So be careful when you put them back in your kit that you've deactivated your power module. Okay, now why are we using a power module? The reason we are using a power module is, let me find the more suitable view to come back over here. The reason that we are using the power module is that we don't want to use our Arduino to be a power supply for the motor and the motor controller. We want to power our project from this board, and then we want to control it from the Arduino. So we are going to control from the Arduino, and we are going to power from the power board. And so if we look at our power board, where did we get power for the chip? We got power for the chip from the power rail, okay? But on control, where do we get the power for the potentiometer? We get the power for the potentiometer from the Arduino. So if you just came in and tried to control, or if you came in and tried to power a motor from the Arduino, you very well could draw more current than what the Arduino can provide, and you can burn out the Arduino. So it's not good to use your Arduino as a power supply. So we will use this separate power supply. Now, what we find for this little motor in the Sunfounder kit, the maximum current that it will draw is 800 milliamps. And then if we check what the TA6586, what current it can provide plenty of current, so the 800 milliamps is not a problem. And then when we come and we look at the power supply, it can provide over an amp, and so it is okay too. So the power supply can run the motor controller and can run the motor. Now, if you're just coming in randomly with a random different motor and a random different motor controller, you want to make sure that your power supply has enough current to drive the motor and the motor controller, and that the motor controller can handle the current that the motor needs. And so you have to do that for whatever your project is going to be. Don't just assume that any old motor that you bring in is going to be able to be powered with this power supply and this motor controller. Okay, I hope that makes sense. So we're powering it from the power module, and we're controlling it from the Arduino, specifically from pins 9 and pin 10. I think that should be pretty clear. Now, I guess the one other thing that I should say is, what does this button do? Well, it's going to start when you run your program. This is going to start in the off position. The motor's going to be off. If you press the button once, it's then going to go forward. If you press the button a second time, then it's going to go in reverse. So it's going to go off to forward to reverse. If you press the button again, off, forward, reverse, off, forward, reverse. So every time you press that button, it is going to advance between that sequence. And so rather than keep track of off, forward, reverse, I just want to kind of go, the number 0 is going to be off, the number 1 is going to be forward, and the number 2 is going to be reverse. And so what I'm going to do is I'm going to use the modulus function, which tells you the remainder. So I'm going to count the button pushes. I'm going to keep track of the button pushes. And then if I do CNT mod 3, this gives me the remainder when you divide the button count by 3. So let's say that I have pressed the button 3 times. 1, 2, 3. If I have pressed the button 3 times and I divide by 3, what is the remainder? 0. I'll come here and that would be off. So I would start off 1, 2, 3. Now if it was 4, 4 divided by 3, the remainder is 1, and it would be going forward. If I put in 5, 5 divided by 3, the remainder is 2, and it would be here. So if you do this, keep track of the number of times the button has been pressed, keep track of the number of times the button has been pressed, and then do the modulus function 3, then what it will do is it will just hop down like this and then hop back and then hop down like this and hop back. It'll just do exactly what you want. So that's how I'm going to control the off, forward, backwards, off, forward, backwards. That's how I'm going to control it. Okay, now what I'm going to do over here is I'm going to read the value from the potentiometer, and then I'm going to use this calculation to calculate the speed. Now, the one other thing that I should show you that we got to be careful about, going from off to on, going to off to forward is not a problem. But when we go from forward to reverse, this we've got to be very careful, because you don't want to be going full speed forward and then just switch the thing to full speed reverse. You want to be going full forward. You want to stop it, give it a second to wind down, and then go the other way. So when we go from here to here, we need to make sure that we put a step to turn it off for a second to give the motor time to wind down. Okay, so that is that. Let's come over here and let's see if we can look at this and just kind of get a quick look at this thing in real life. Okay, get a quick look at this thing in real life. And so you see I've got the motor, I've got the motor controller, I've got it hooked up to the Arduino, I have the potentiometer. The potentiometer is coming up and being powered from the Arduino and not from the power rail. And so what is being powered from the power rail is this chip. This chip is being powered from the power rail, and that is the only thing that is connected to this power supply. The one other thing that I should say, and I should have said it a minute ago, is, let's see if I can see this here. Okay, when you're using different power supplies, you have to make sure all the grounds are connected together. Okay, and so what I've had to do is I have had to run a wire from this ground rail to the Arduino ground. Okay, so the Arduino ground has to be connected to the power supply ground. When you have a circuit, all of your grounds need to be connected together. So the potentiometer, the ground wire goes to the ground rail. The button, the ground wire goes to the ground rail. The TA6586, the ground wire goes to the ground rail, and then the Arduino, a ground comes over to the ground rail, and that way all of my grounds are connected together. Okay, we have done a whole lot of talking, and I think we're ready to come in and we're ready to start coding this thing. So let's see if I can get configured here to start doing that. Give me just a second. All right, so first thing we're going to do is we are going to set up our variables. And so we have this thing called motor speed, which will be that number between 50 and 255 that we apply to either that GPIO pin 9 or GPIO pin 10 to make the motor run either forward or backwards. But we're going to calculate that, so I will not give that a value because we'll calculate it, but I will declare it. Okay, now we had that backward input, and that was pin 10. All right, then we had the forward input, and that was pin 9, like that. Then we had the pot pin, the pin for the potentiometer, and that we went to A0, the analog input A0. And then we had the button pin, butt pin, and we saw that went to pin 7 on the Arduino. we have but count. That's how many times has that button been pressed. We're going to keep track of that in but count. That's going to be 0. Okay, it's going to start with 0 because when you run the program, it hasn't had the button pushed yet. It will start at 0, but count. And then we're going to be reading the button state. Everything through the loop, we're going to be reading whether the button has been pressed or not. And so that is going to be the but val. And that will start out at 0, just to give it a value. And then the but val old, okay, is equal to 0. So if you have used a toggle button before, you know you need to keep track of this time through the loop, where is the button? And then the next time through the loop, where is the button? So this time and last time. So we have but val is the button value this time, but val old was the button value the last time. And we are going to be using a pull-up resistor, an internal pull-up resistor. And so this button, if it is in the up position, the unpressed position, you will read a 1. If you press the button down and it's in the down position, you will read a 0. Why? Because we're using a pull-up resistor. Okay, so we've got that done. And then also we are going to be reading from the potentiometer. So we're going to need a PV for potentiometer value like that. And then also remember, we're going to modulus that number, that button count number, that but count, we're going to modulus at 3, and then that will give us the remainder, but I'm going to go ahead and set the remainder to 0 the first time through, like that, okay? And then that rem is going to go 0, 1, 2, 0, 1, 2, like that. Okay, hopefully that makes sense. If any of this seems complicated or foreign, go back and watch last week's lesson because I really went through this a lot more detail last week. Alrighty, we need to do our pin modes now. So I'm going to say pin mode, and which pin? The backwards pin, the backward input, and that is going to be an output pin. Okay. That's kind of strange. It's an output for the Arduino, but it's an input for the motor controller. So that's the way you got to think of it. Then I'm going to do a pin mode, and then what do we have? The forward input, and that is going to be an output as well. All right, now I'm going to have the pin mode. I'm going to have the pot pin. That's an input because I'm going to read from it. Okay, and then I'm going to have the pin mode, and then the famous but pin, and that is going to be an input, but we also want to activate that internal pull-up resistor, and so we needed to put up underscore pull up. And I've got a whole list on this earlier in this class, or an earlier video. You can go back and learn about the toggle switch and the internal pull-up resistor if you want to, but we're just going to use it here. Okay, now what do we want to do at this point? I want to just look over this. I might want to print something out, so I better go ahead and do a serial.begin 9600. I don't know if I'll print anything, but I'll go ahead and turn that on just in case we need it. All right, now we're going to come down, and the first thing that I'm always going to do is I'm going to see, what is the button doing? Where is the button? So what I need to do is I need to read but val, okay, and that's going to be a digital read. Where am I going to read the but pin? Because I want to see, has the button been pressed? All right, so now I have a but val. Now, if but val equals 0, that means what have I seen? I have just seen that the button has been pressed, and if it's that, and but val old equal 1. So that means if last time the button was up and this time it's down, that means I have a what? I have a button push. And in that case, if I get a button push, what do I want to do? What do I want to do? Now see, This opens and closes the if clause, and then this closes the void loop. So that all looks good. Okay, what do I want to do? Well, if the button is pressed, I want but count to be equal to but count plus 1, like that. Okay, that looks good. Now, what we've got to do here is we have to remember for the one case here, if I'm going from forward to reverse, I want to stop it. Well, what would the REM be in that case? If the REM is 1 and I get a button push, I want to turn the motor off so that I don't switch the direction too quickly. So what I'm going to do is I've got my but count there. That's good, but now I'm going to say if the remainder equal 1, that means I'm presently going forward. I'm presently going forward and I've gotten a button push. Then what do I want to do? I want to analog write Fi down to 0 and then analog write Bi down to 0. Bi should already be 0, but I'm going to set them both to 0 just to make sure that I'm thinking about this right. And then what am I going to do? I'm going to give it a delay of 1,000 milliseconds. So what does this mean? If I'm going to go from forward full speed to reverse full speed, I'm going to turn the motor off, let it wind down for a second, and then I can continue on with the rest of the program. Okay, so now we have that delay in there. We've got that delay in there. So I've closed that if statement. Now I have closed this if statement. I've closed the two if statements, and now I'm ready to be back again in my main loop. All right, what should I clean up before I do anything else? I just need to make sure that I make but val old. Since I've just done all my but val stuff, I need to make the but val old equal to but val. So next time around the loop, today's but val is going to be but val old the next time through the loop. So we just need to go ahead and do that. And if you forget to do that, it's a very hard job to debug it. All right, that all looks pretty good. So now, what did I get up here? I've got now a new but count, and if I have a new but count, I need to get a new remainder. So the remainder is equal to but count modulo 3. So that's saying but count, divide by 3, and report the remainder. So like 7 divided by 3 would be 2, but 7 mod 3 would be a remainder of 1. So the thing you would get back here would be a 1, as I explained earlier, but that might be a little bit of a new concept for you. Okay, now I'm going to need to read the potentiometer. So the PV, the potentiometer val, is equal to analog read of pot pin, like that. That looks good. Okay, now I need to get that motor speed. And remember, I gave you that equation that was 205 point divided by 1023 point. Why am I putting the point in there? 205 the integer divided by 1023 the integer. It will give you the integer result, which is 0. And it's very hard to find that error. So I'm using 205 point divided by 1023 point to force floating point math on that, okay? And now we said we would multiply that by the PV and then add 50, and I derived that equation last time, so I don't derive it again today because most of you guys, I think, are taking this class and you saw the last lesson. Okay, now what are we going to do? Now I have a remainder. I have a speed that I want to operate at, and I have a remainder. So what we do depends on the remainder, right? So if the remainder, if the remainder equals 0, what did we want to do if the remainder equals 0? Well, we want to turn it off. Analog write FI 0 and analog write BI 0. So BI 0. So what are we saying? I want the forward input off, the backward input off, then the motor will be off. Now guys, this is something really peculiar, and I don't think this was true for the Arduino Uno R3, but for the R4 Wi-Fi, once you do an analog write to a pin, you can't go back and do a digital write. And so I was just doing analog write if it was in between, and then if I wanted something else, I would do an analog write. Analog writes and digital writes don't mix. That when you define the pin, once you use it as analog, it's analog. Once you use it as digital, it's digital. But don't try to, within a single program, mix analog writes and digital writes to the same pin. Peculiar, but I think it's a little bit of a bug. Okay, so that we have done, all right. This closes the if statement, and this opens the if statement, this closes the if statement. So now what do I want to do? If REM equal 1, what do I want to do if REM equal 1? Well, I want to turn it on. And so in that case, I think that I'm just going to copy these. I'm going to copy these and put these in. And this time what I will do is if I am here and I go to 1, I want to turn it on. So instead of writing a 0 to it, I'm going to write that MS, that motor speed to it. And then this would stay 0. Okay, now that's that case. And then if REM is now 2, and don't worry that we turn the motor off up in that original button push, so we don't have to worry about it here, because if it gets here, it's already turned the motor off. So now we are going to do the analog write. Forward this time is going to be 0 because we want to go backwards. So we'll put the MS here like this. Wow. Okay, then this closes that last if statement. This closes the void loop. How many mistakes did I make in here? I think I can almost hear you all screaming at me now. But the first thing, I just want to kind of make sure I haven't finished my, haven't skipped my semicolons. You know, I've been doing the Arduino now for a few weeks, so I'm getting back in the habit of using my semicolons. So that's pretty good. Okay, now what you see, one thing I need to do here is I have been charging up my battery module, so I need to take that off. And I need to come back over here and put it in the Arduino, because this is a little bit of a pro tip, but it is hard to download the code. It is hard to download the code if you don't have the USB connection there. Okay, so now what I'm going to do is I'm going to turn this on. Okay, and so the power is on. So now I have power available to the motor. I've got power available to the motor controller. Everything's ready to go. Now I'm going to download the code, but remember I started it in the off position, so I don't, what? MS, what is that MS equal? It should be MS, like that. I don't know how that equal got there. First line of code, yeah, what is this? But val is equal to digital read of but pin. But val, did I not declare that up here? I thought for sure, but val. That's a typo. But val, okay, let's try it again. You guys probably just typed but val right along with me, didn't you? Okay, it is downloading. All right, now I'm going to set the motor speed low, so I'm going to turn my potentiometer all the way to the left. I guess one other thing I should show you is if you want yours to work like mine, that was crazy. If you want yours to work like mine, put it in this direction where that center leg, you see that center leg is pointed that way. So you have back here, you have the left pin and the right pin, and the center pin is forward. And if you plug yours in upside down, you're going to get backwards results from what I am. But now I've turned that all the way to the left, and it's off. So far, everything is kind of like what you expect, but I'm going to come in here and I'm going to now press the button one time. Boom! It is on in the forward direction. Now, if I press it a second time, it stops and then it reverses. Did you see that second delay in there? It had the chance to slow down and stop and then reverse and then button. It's off. So it's off, forwards, backwards. Off, forwards, backwards. Off. Okay, now let's turn it forward, and now let me begin to turn the speed up. Okay, you can't tell, but it is really starting to crank. It is really starting to go. Yeah, it's trying to take off. Now that's full speed. All right, let's go back to the slow speed or a little bit in. Now let me stop it. I'm sorry, that's the backwards. And now it's going very fast in the backwards. So the speed control is working forward. The speed control is working backwards. And the button off, forward, backwards, they're all working. Notice they give you a little plastic thing there, like a flimsy plastic thing, because you see I've hit my finger on that like a few times already. So off, forwards, off, forwards, backwards. Okay, it's working like we expect. Okay, now let's talk about something here. So I'm going to turn it off. Wouldn't it have been a lot easier if I had powered this potentiometer here, the left leg of the potentiometer, just come and snag the 5 volts off of this instead of getting the 5 volts off the Arduino? Well, let's see what would happen. I'm bringing the wire and now I'm connecting it to the power rail, which is 5 volts. It's 5 volts here, just like it's 5 volts there. Technically, I should be able to get the 5 volts here. But if I turn it on now, what's happening is you can't see it, but it's pulsating. And the faster that I try to run it, the more that this thing is pulsating in a very, very poor way. Okay, the more I'm getting a very unexpected result, and the thing is not running smoothly at all when I do what I just did here. So let's see if we can figure out what is going on. Like, why does this not work if I'm reading the potentiometer from the power rail, from the power module, instead of getting the 5 volts from the Arduino? So let's come over here, and I have a nice oscilloscope here. Okay, I have a nice oscilloscope here. And what the oscilloscope is looking at, is it's looking at this power rail. So I have the plus lead of the oscilloscope to the power, and I have the minus lead of the oscilloscope to the ground. And so I am able to look at the voltage that I am getting out of this power module. Okay, so let's look at that voltage. You'll be looking at the oscilloscope here, and I'm going to turn this on. And look at that, boom. I have 2 divisions. This is 0 volts, and I am at 2.5 volts per division. So boom, I am getting a beautiful, perfect, stable 5 volts out DC out of this. So I turn it off. It goes to 0, I turn it on, and it goes to 5. All right, pretty neat. Okay, I can't help it. What if I move these jumpers to 3.3? You see, now I'm getting a 3.3 volts. If I move the jumpers to off, I'm getting nothing. If I move the jumpers to 5 volts, I'm getting 5 volts. Isn't that a lovely little motor, a lovely little power supply for the breadboard? Okay, but now what happens if I turn the motor on? Okay, look at that. Do you see all of a sudden I get this huge noise signal on the oscilloscope. Now, if this is going to the potentiometer, it is not seeing a pure 5 volts. It's seeing something more than 5 volts and less than 5 volts. And so even while the potentiometer is sitting and not moving, its bias voltage is changing. Therefore, the voltage divider, the voltage on that center leg, is going all over the place. And so this potentiometer is telling the motor controller, go fast, no, go slow, fast, slow, no, go 5. So it's giving a very confused signal to the motor controller, and that is why the motor is not working very well. You guys, if you do not have an oscilloscope, you really need to think about getting one. You don't have to have one for this class. I always make sure everything I do, you can do without it, and you can just watch me do it. But you can see if you were really trying to debug this thing in real life and didn't know why the motor wasn't working, it would be very hard if you couldn't come over. If you were not able to come over and look at the voltage signal in the look at the voltage signal on the oscilloscope. Okay, so I'm going to turn this off now. I'm going to turn it off, and then what I'm going to do is I'm going to get the oscilloscope, and I'm going to connect the power. I'm going to connect the potentiometer back to the 5 volts on the Arduino. And now I'm going to look at that 5 volts coming off the Arduino. If I can get over here. Okay, I'm going to look at the 5 volt signal. We got to admit, this is just a mess. There's no way to do this pretty, right? There's no way to do it pretty. But what I've done now is the oscilloscope is looking at the 5 volts coming off the Arduino and not the 5 volts coming off the board. So you see now, if I turn the board off, you're still seeing 5 volts here. Why? Because it's getting that 5 volts off the Arduino. Now I turn this on. It's still perfectly clean, perfectly beautiful 5 volt supply. Now let's turn the motor back on. And you can see we're getting a very, very nice 5 volts. There's a little tiny bit of noise that's coming from the motor all the way back to the Arduino, but it is not enough to affect the operation. And so I am getting very, very smooth and very, very nice control of the motor. Okay, guys, I am going to switch this thing off. I hope you've enjoyed this lesson. I just got to emphasize the concepts that I've taught you here are generally true for DC motor control, but you've just got to make sure that your power supply and your motor controller can handle the DC motor that you're running. Now, you might ask me, well, what if I wanted to control this off of this power supply? Well, what I would need to do is I would need to come in and build a filter to filter out all that electrical noise. and designing that filter, you would need capacitors and resistors of specific values. And in our kits, we've got just like 2 different sizes of capacitors, so we couldn't design a filter that would specifically filter out that signal that we're seeing. So I can't really do that in today's lesson. Maybe someday I'll have you order some variety of capacitors and resistors, and we could look at how to build a little filter, a little electronic filter to take care of that particular problem. But for today, what we did was we just went and we got the signal off of the Arduino. Okay, guys, I hope that you are enjoying taking this class as much as I am making it. As always, I want to give a big shout out to you guys who are standing with me on Patreon. Right now, it is the Patreon support that allows me to continue to produce fresh, new quality content every single week and put it out there for you. So you guys supporting that, thanks a lot. You can also support this channel by giving me a thumbs up and leaving a comment down below. That'll help me with the old YouTube juice. If you haven't already, subscribe to the channel. When you do, ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.